Welcome back students to our free learning platform Catalyst for IIT JEE. This is the second lecture of the lecture series on basic concepts of chemistry, and in this lecture we are going to talk about the laws of chemical combination in detail, mole and molar mass concept. We are also going to talk about the atomic mass concept and percent composition. Okay, now at last we will talk about the concept of limiting reagent as well. This concept of limiting reagent is very important, and most of the time we see a question from limiting reagent concept. So if you have liked our platform and if you are following our platform and video lectures, please share it with your friends, because we want students to know about this platform, this free learning platform, where they can start preparing from the zero knowledge, from the scratch. Okay, now if you have not subscribed as yet, please do subscribe and hit the bell icon so that you get continuous notification from our channel. Now let's move to the concept of laws of chemical combination. Now the laws of chemical combination, from the term itself, what you can understand, you can see there are certain laws. There are mainly 5 laws, and which are essential for chemical combination. Now what do you mean by chemical combination? Chemical combination means that how 2 or 3 elements or 2 or more elements will add or combine to form a compound. Okay, so in what ratio they are going to mix together to form a compound, in what there are a set of laws, in what volume ratio, or in what mole ratio or mass ratio, how they are going to form a compound. So there are 5 laws, and the first law is the law of conservation of mass, which has been proposed by Antoine Lavoisier. The second law is law of definite proportions. The third law is law of multiple proportions, and it is proposed by John Dalton. The previous one is proposed by Proust. Gay-Lussac's law of gaseous volume was proposed by Joseph Gay-Lussac, and Avogadro's law was proposed by Amedeo Avogadro. Now we will discuss these laws one by one, and we will try to understand these laws first. Now first, the law of conservation of mass. From the concept, the law of conservation of mass. Conservation of mass means that you are conserving the mass, or so the mass is not going to change. Now what experiment Antoine Lavoisier did? He first saw that when you heat a metal mercury, it forms reddish orange product. Okay, that clearly tells you that when you heat mercury, you get some different product, which is generally the reaction of mercury with aerobic oxygen, and the mercury gets oxidized to form this reddish orange product. Now what he did, he placed some mercury inside a jar and then sealed the jar and then recorded the total mass of the setup. So this is before the reaction, the total mass he obtained. Okay, now what he did, he heated the jar. But he heated the mercury inside the jar. Now as the jar is sealed, no gas can come out of the jar, or no extra gas from the atmosphere can go inside the jar. Now then, after heating, then he again took the weight of the jar. He recorded the mass of the jar. Now what he observed that the mass of the jar and its contents inside, whatever he had put in, had not changed. Now he concluded from the observation, he concluded that matter can neither be created or destroyed. You can change the form of the matter, but you cannot create or destroy a matter. Now as for example here, when you add carbon plus oxygen and you get carbon dioxide, this is the case. If you do this reaction inside a jar and then you mix 12 gram of carbon with 32 gram of oxygen, you will get 44 gram of carbon dioxide. Now if you see the mass of the reactants, total mass is 12 plus 32, which is equal to 44, is exactly equal to the mass of the product CO2, which is 44 gram. Okay, so the next law is the law of definite proportions. This law has been proposed by Joseph Proust, and what he took two cupric carbonate samples and then analyzed those samples. How? Now the first sample of cupric carbonate was collected from a natural origin. Now you get cupric carbonate in many forms automatically from nature, and he collected that cupric carbonate sample. Now the sample 2 was prepared synthetically. Now then he went to the lab and then he synthesized cupric carbonate. Now in both cases we are calling it cupric carbonate, but the origin of those two cupric carbonate are different. Then what he observed that in both the samples, percent composition of elements was exactly same. What do you mean by percent composition of elements? I will tell you now. Now from the observation, what he concluded that a given compound always contains exactly the same proportion of elements by weight. Now a given compound, which is cupric carbonate here, always contains the exactly same proportion of elements by weight. So the weight of cupric carbonate has the formula is like this, CuCO3. Now the same proportion of elements, that means the percentage of copper, weight percentage of copper in the cupric carbonate is exactly same, and it does not change even if you change the source of the sample. Like cupric carbonate from the nature and cupric carbonate from the laboratory will have the same proportion of copper, same proportion of carbon, and same proportion of oxygen. As you can see, that is why the formula, the molecular formula is exactly same for both the cases. Now the similar example is like water. If you take water from your home, if you take water from a pond, and if you take water from the sea, the water composition is not going to change. The percent composition of water is not going to change. Like the water will have the formula H2O in all the cases. So this is the law of definite proportions. The third law is the law of multiple proportions. Now the law of multiple proportions is proposed by John Dalton, and according to the law, if two elements can combine to form more than one compounds, okay, so this is what you need to understand clearly. Now if two elements can combine to form more than one compounds, like here hydrogen and oxygen, it can form H2O, which is water, and hydrogen and oxygen, it can form hydrogen peroxide, which is H2O2. So if two elements which are hydrogen and oxygen here can combine to form more than one compounds, which are H2O and H2O2, the masses of one element that combine with a fixed mass of the other element. Now as you can see here, the mass of hydrogen is 2 gram and 2 gram in both the cases. So the fixed mass is for hydrogen, and the other element, which is oxygen, is having 16 gram here, but in case of H2O2 you need to add 32 gram. Now what the law says, the masses of one element, which is oxygen, that combine with the fixed mass of the other element, which is hydrogen, are in the ratio of small whole number. Now this 16 gram and 32 gram, what you can do, if you calculate the ratio will be 1:2, which is a simple whole number ratio. So this is the law. So I hope you understand the concept of law of multiple proportions. Now let's move on to the next law, which is Gay-Lussac's law of gaseous volume. This law has been proposed by Gay-Lussac, and the observation he proposed that from the observation he proposed that when gases combine or gases are produced in a chemical reaction, they do so in a simple ratio by volume when all the temperatures and pressures are kept constant. Now if you consider this water formation reaction from hydrogen and oxygen, what you observe that these are gases, hydrogen and oxygen. Now when they produce a molecule in a chemical reaction, these two gases will have the simple ratio by volume. Like if you mix 100 ml of hydrogen with 50 ml of oxygen, you are going to get 100 ml of water. Now this volume ratio of hydrogen and oxygen is 100:50, correct? So this is 2:1. Now this 2:1 is a simple ratio by volume, correct? So this is the law. This is a very simple law, and I hope that you understand this law very clearly. Now the last law is the Avogadro's law. Now Avogadro's law is very important, and this law says that equal volume of all gases at same temperature and pressure should contain equal number of molecules. Now Avogadro also distinguishes the atom and molecules. Okay. Now from the law, what it says that equal volume of all gases. You take 100 ml of oxygen, you take 100 ml of carbon dioxide. In all cases, the number of molecules are going to be equal. At 25 degrees centigrade and 1 atm, if we considered, which that means that you are keeping the temperature and pressure constant, and at this constant temperature and pressure, if you calculate the number of molecules in 1 liter of oxygen, this is going to be exactly equal the number of molecules in 1 liter of carbon dioxide, because you are not changing the volume. Okay. Now if you change the volume, what will happen? That means that if you are changing the volume, you are increasing the number of molecules as well. So at constant temperature and pressure, volume is proportional to the number of molecules. Now we also know that number of molecules are proportional to number of moles. So if you add more number of molecules, your mole number will also increase. So this concept from how you can relate molecules number of molecules with number of moles, we will come to that later. But at this point, please remember that volume is proportional to the number of molecules, and thus we can write volume is proportional to the number of moles. This is a very good outcome of Avogadro's law, and this is another way to express this Avogadro's law. Now let us understand the concept of atomic mass, average atomic mass, and molar mass, etc. Now atomic mass is the mass of one atom, correct? This is very simple. Now how do we measure the mass of an atom? Because the atoms are very tiny, correct? Now at this point we have very sophisticated instrument, and the instrument is called mass spectrometry. Using this mass spectrometry, you can calculate very precisely the mass of an atom. But how does the mass of an atom is calculated when there were no mass spectrometer? So how do you calculate the mass of an atom? Now the lightest element was hydrogen, correct? They considered that lightest element, hydrogen, has a mass 1 atomic mass unit. And now the mass of other elements were calculated with respect to hydrogen. Okay. But later what happens? Later they found that the mass of hydrogen is not exactly 1 AMU, but the mass of carbon 12, which is the 12 carbon isotope of carbon, has exact mass of 12 AMU. So they later changed the relative thing from hydrogen to carbon 12, and they considered that carbon 12 is the standard for this mass calculation. And what they did, they calculated the mass of every element with respect to relative to this carbon 12 mass. Okay, so atomic mass then was defined as the mass of an atom relative to the mass of a carbon 12 atom. Okay. Now, before we try to understand the average atomic mass concept, we need to understand the concept of isotopes. We'll discuss about these isotopes in detail in our atomic structure classes. But before that, here just try to understand it in a very brief way. And the isotopes are elements having same atomic number but different mass number. What do you mean by atomic number? Atomic number is the number of protons in the nucleus, correct? But what is mass number? Mass number is the summation of your proton number plus neutron number in the nucleus, correct? Now, if we consider these three elements, which is 16 oxygen 8, 17 oxygen 8, 18 oxygen 8, you can clearly see the atomic number in all these cases are 8, which is the number of protons, correct? But the mass number are different, which is 16 plus 17 plus 18. Now, mass number is the number of protons plus number of neutrons, but you have already seen that number of protons is 8 here in all these cases. So, number of neutrons are different here in all these cases. Here the number of neutron is 8 because 16 minus 8 is number of neutron, which is 8. Here the number of neutron is 17 minus 8, which is equal to 9, and here the number of neutron is 18 minus 8, which is equal to 10. Now, as we can see here, the number of neutrons are different here, but the number of protons are same here. So, these are called the isotopes of oxygen, okay, where the protons number of protons are same, but the number of neutrons are not same, okay. Now, so average atomic mass, how do you calculate average atomic mass? In nature, there is not just only carbon 12, there are carbon 13 and carbon 14 as well. But the relative abundance means the presence of the isotope in nature, okay. Now, carbon 12 is majorly present, which is the abundance is 98.892%. Carbon 13 has relative abundance 1.108 and carbon 14 has relative abundance 2 into 10 to the power minus 10, which is very small. Now, the atomic mass of carbon 12 is 12, carbon 13 is here given here, and carbon 14 is given here. Now, if you want to calculate the average atomic mass, what you need to do, you need to calculate this the average one by multiplying this relative abundance into atomic mass, okay, relative abundance into atomic mass, and you sum all over these three isotopes, and then you get 12.011 atomic unit, okay, atomic mass unit. So, this is how you calculate average atomic mass, and I hope that you now understand the concept of atomic mass and average atomic mass. Now, let's understand the concept of molar mass and mole concept. Molecular mass or molar mass is the summation of atomic masses present in the molecule, okay. That means that if you want to calculate this molecular mass of CH4, you have two types of atoms, carbon and hydrogen. Now, if you want to calculate the molecular mass of this molecule, you need to add the atomic masses of these atoms, okay. Now, carbon has this atomic mass 12.011 atomic unit, and hydrogen, you have 4 hydrogen atoms, so you need to multiply 4 with your atomic mass of hydrogen, 1.008 atomic unit. Now, you get 16.043 atomic unit, or we can also write 16.043 gram per mole. That means that 1 mole of CH4 will have the total mass 16.043 gram. Now, the molar mass of carbon dioxide can be calculated similarly, and what you get 14.011 gram per mole or 14.011 atomic unit. Now, the mole, the concept of mole comes because one molecule or one atom is very tiny and the mass of one atom is very small to determine, okay, or to measure all the time very frequently. So, the concept came that if you calculate a sufficient amount of a molecule, okay, which is measurable, like if your mass is 1 gram and you went to a shop, but 1 gram is not possible to measure in that shop, okay. So what you do, you take sufficient amount like 1 kg which is measurable, and then now come back and count what is the number of quantity you get. So you increase the quantity, okay, to reach a sufficient amount. So the mole concept came for the similar concept in the similar way, and 1 mole is the amount of a substance that contains many particles, okay. So total mass of the content or all the atoms will have exactly 12 gram for carbon 12 isotope. Now for 16 oxygen isotope there will be 16 gram, the mass will be 16 gram. So there will be a number of your oxygen atoms, okay. So 1 mole is found out that the number is 6.023 into 10 to the power 23, and this number is called Avogadro's number. Now as you know that unit of mass is gram, unit of molar mass is gram per mole, correct? So mass, if you divide mass by molar mass, what you are going to get? You are going to get gram by gram per mole, and so finally you are going to get mole. So mole is nothing but the mass divided by the molar mass, okay. So now the concept of formula mass comes in, and there are some compounds that do not exist as discrete molecule like NaCl. So discrete molecules like NaCl, so if NaCl is discrete, then it should be described as structure A, but in real cases the NaCl exists as a solid, and it exists like this, which is the structure B. Now in this case we do not know exactly what is the lattice size, what is the solid extension. So there are many NaCl atoms and chloride ions there, Na plus ions and chloride ions there in the solid. So it is not possible to calculate, to consider all the atoms and all the chloride atoms to calculate the molar mass. So in this case the concept of formula mass comes in, and you calculate the formula mass by adding the atomic mass of the atoms present in the formula of the solid. So what is the formula of the solid? It is NaCl, okay. Now for NaCl the formula mass will be the atomic mass of sodium plus atomic mass of chloride. So now by calculating or by adding these two atomic masses you get 58.5 gram per mole. Now the percent composition, the concept of percent composition is quite similar, and if you know the molar mass of water, let's take this example, molar mass of water is 18.016, and hydrogen present in H2O will be your 2H, like 2 into 1.008 gram, because the atomic mass of hydrogen is 1.008 gram. Now the oxygen present in H2O will be your 16 gram, correct? So if you calculate the mass percent of hydrogen, the percentage will be 2.1002 into 1.008 by the total mass of water into 100%. So in total water mass, the percentage of hydrogen present, the mass percentage is 11.19%. So the rest of the mass percent will be of oxygen. So mass percent of oxygen will be your 100 minus 11.19, which is 88.81%. So these problems, these definitions will become much more clear when you start solving some problems from it, and in our next video we will come with some basic problems on this percent composition, concept of mole, concept of molar mass, etc. Now this is a very important concept you need to understand, which is the concept of limiting reagent. And to understand this, let us consider this reaction carbon plus oxygen is equal to is giving you the product carbon dioxide. Now clearly 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. How do you know that? You know it from this stoichiometry. Now in this stoichiometry you have only one carbon, one oxygen molecule, and you get only one carbon dioxide molecule. So you can write that 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. Now let us consider that we have 2 moles of carbon and 1.5 moles of oxygen. Now as you know that 1 mole of carbon will react with 1 mole of oxygen, here you can see that 2 moles of carbon you need 2 moles of oxygen, correct? But you have only 1.5 moles, so we are short of oxygen. Okay. Now in other words you can say that you have excess carbon. Now how much excess carbon do you have? You have 1.5 moles of oxygen, correct? Now which will react with 1.5 moles of carbon. As you know that 1 mole of oxygen reacts with 1 mole of carbon, you have 1.5 moles of oxygen which will react with 1.5 moles of carbon. So excess amount of carbon will be your 2 minus 1.5 moles, which is 0.5 moles, because you have initially 2 moles of carbon, correct? Now because the less amount of oxygen, so there is a less amount of oxygen which limits the reaction to continue further. Okay, so the reaction gets to the end point because you have less amount of oxygen. So you can also say that because of the less amount of oxygen, the oxygen limits the reaction to continue further. Okay, even if you have other reagents in excess. So the limiting reagent is here, the limiting reagent is oxygen. Okay, so this is the concept of limiting reagent, and I hope you understand the concept of limiting reagent. This is very important, and we'll come with some problems to understand it better and to solve some MCQs in your exam. So we also understand the percent composition. So this is mass percent is quite similar, and these concept, this mass percent, mole fraction, molarity, molality are generally true or generally applicable for solution chemistry. And mass percent is in solution, there are two parts, correct? Solute plus solvent. So mass percent of solute can be calculated by mass of solute by mass of total solvent into 100%. So this is the mass percent. Mole fraction is a very important concept, and you can calculate mole fraction of a species by this formula, where Ni is the number of moles of the species, ith species, and capital N is the total mole in the mixture. Now molality is the term by which you express the concentration of a solution. Okay, the number of moles of solute present in 1 liter of solution. So this is very important. In 1 liter of solution, how many moles you have, how many solute moles you have. Okay, so molarity can be expressed as this number of moles of solute by volume of solution in liter. Molality is also another concept by which you can express the concentration of a solution, and the molarity is defined by the number of moles of solute by the mass of solvent in kg. So per kg of solvent, what is the number of moles of solute present in the solution? So this is known as molality. So molality concept is useful in colligative properties. You will get to know about this in your solution chemistry lectures. So in this lecture we discussed a lot of things. We discussed law of conservation of mass, law of definite proportions, multiple proportion, Gay-Lussac's law of gaseous volume, Avogadro's law. We also discussed about atomic mass, average atomic mass. We discussed about isotopes, molar mass, molar concept, formula mass, percent composition, and finally we discussed about limiting reagent, molarity, mass percentage, etc. So if you like this video, please like, share with your friends, families, and all of your juniors. And if you know someone who is a potential candidate for IIT JEE or NEET, or maybe he or she is appearing for board exam, you can suggest to them and you can share our channel to them. And if you have not subscribed us yet, please do subscribe and hit this bell icon so that you get continuous notification from our channel when you upload a new video. Thank you very much for your attention.